Welcome back. Today we're going to be looking at Matplotlib, and particularly the Pyplot submodule. So Matplotlib is a library for drawing graphs, but the main submodule that has most of their functions is called Pyplot. And Matplotlib is really great for drawing graphs. As you can see, you can do all kinds of graphs, and these aren't the only ones, but these are the samples that they give on their website. So why don't we just go straight in and start drawing graphs. So we'll start by importing matplotlib.pyplot, and we'll call it PLT, which is standard. We'll also need pandas, and that's PD, and we want to import numpy as NP. And so we'll start by creating a data frame. This will be a pandas data frame, and we want the columns in this to be the weight and the height. And the reason I've got brackets there is to make that a tuple for the columns. Then we want to set the weight, and it'll be a normal distribution that's random. So we use the numpy random submodule and then the normal function, and we want to specify log, which is the mean, to be 70, the scale to be 5, so that's the standard deviations of the data, and the size is going to be 1000. So that means we're going to have 1000 items in our numpy array, and it's going to be a 1D array. And then we can repeat with the height, so that the values this time are going to be 1.8 and 0.05, and we can just print our data frame. And you can see we've got some values for the weight and some values for the height, and usually there'd be some kind of correlation between the weight and height, but because these are just random, there's not going to be any. But what if instead of printing the data frame we could plot it? So we can just do plt.plot df. And you'll notice nothing has happened, and that's because at the end we need this plot.show to display our plot. And so if you ever draw a graph and nothing turns up, it's probably because you've forgotten that. And I mean, this is alright, we've got some data here, but you can see it's plotted it as a line graph because we've got indices here. So this isn't that useful. So let's try again with something a bit better. So really the kind of plot that we want is a scatter plot. So we could do just plt.scatter, and on the x then we'll put the weight, and on the y put the height, and again it's showing it at the end. And already that's looking a lot nicer. A couple of things we're going to change though is we'll customize it so that it has a marker, which is an X, so we're using crosses instead of dots, and the colour is black, just because I think that would look nicer. And you can see it's displayed our data again, and we could even make this full screen, and then it's a bit clearer. But I think it would be nice to put multiple graphs on. So what we want to do is we want to say that we have a figure and some axes, and we want to create subplots, and the dimension of these subplots are going to be 3 by 2, so we're going to end up with a grid that's 3 by 2, and then we'll set the first one, so that's 0, 0, which is a subplot, and we'll just put this in, so we'll draw a plot there. and you can see it's created all our plots, and it's put the first one there. Although one thing I don't like very much is this figure 1 title, so we can actually just change that by here changing the number of our figure, but rather than changing it to a number, we just change it to health data, then it will automatically rename it. And you can see now it's called health data, and this is quite small, but when we zoom in it should be a bit clearer. Then we're going to add another plot next to it. So these are actually done as y and then x coordinates, if you think of it like that. So this is the one to the right. This will be a 2D histogram with the weight and the height. And I'm not going to change the colours because I think they're quite nice. And we can see there we've got a 2D histogram which very nicely represents this distribution over here. And you can see lots of things in the centre, so it's yellow, and absolutely nothing around here, so it's a dark blue. So below that we're going to put 2 histograms, and so we use a coordinate system, and we say we create a histogram, and this time it will be on the height, and then we'll create another one on the weight, and nicely I can just change one letter to get that to work. I'll put those. And you can see that we've got the height and the weight, although we're going to change the colours just so it looks nicer, because after all, if you're plotting graphs, you're probably doing it so that they look nice. And of course there are loads and loads of options you can change, but we're just going to go over the basic ones. So now we've got 2 slightly more colourful graphs. We could also change the number of slots there are, but I think the default works quite well. Now we're going to calculate the BMI, and we're going to add that to our data frame. So we've got a column called BMI, and that's worked out by dividing the weight by the height squared. And that's the reason the weight was in kilograms and the height in meters in the first place. And then we want to plot this, but it would be nice if it could span the bottom 2, so it was a bit wider, because this is kind of our main chart. So what we want to do is we want to create a subplot in a different way. So what we do is we say that our BMI subplot is the subplot of the whole plot, and then we use 3, 1, 3. So if I use this to illustrate, what it's done is it's broken this up into 3 by 1. So 1, 2, 3, and then just 1 across. So if that had said 3, 3, then it would have broken up into 9 individual sections. And then the 3 at the end references this one. So if there were 6, it goes 1, 2, 3, 4, 5, 6. But because there are 3, it goes 1, 2, 3, and so this is the third one. Saying after we've broken it up, it wants to select this one. And we can actually just put in numbers 3, 1, 3 without commas, but it's a lot clearer if we specify that we've got 3 rows, 1 column, and we're selecting number 3. And then we want to plot something on there. So we'll put on a histogram again. I'm going to plot the BMI, and we'll set the colour equal to red. And you can see that it's gone wrong because this needs to be outside, because what it's trying to do is it's trying to find a place in the data frame that matches that, and you can't put keyword arguments when you're referencing, so it's just said it doesn't like it. And you can see that we've got this nice distribution for our BMI. And now I think we should put some titles on, because they're looking a bit blank. So if we start with BMI, then we can say that we want to take the title and we want to set the text to BMI. And you can change the font and many other things, but we'll start by just changing the text. So you can see it's got a label for the BMI. So let's add some labels for the other ones. So we'll take 10 and we'll take the title and we'll set the text equal to height, and then we'll do the same for 11. And you might say, well, how come this one needs to be called BMI, but this one we're using index referencing? And the reason is, this is creating subplots, and this is accessing a subplot. And if we were to use this function to access the subplot multiple times, then it shows up a deprecation warning. So it's bad practice to use it, but we've saved it and we can access it multiple times. We could save all of these, but they're easy to reference. And if we were to try, for example, selecting the bottom two plots using maybe a colon here and a 2 here, then we'd end up selecting a numpy array rather than a subplot, so it would not let us do that. And you can see we've got labels for height and weight, which will be a bit clearer when we make it full size. So for the ones where we've put scatter plots and 2D histograms, we probably don't want that to have a title, but we can instead just give the x and y values names. So if we take the top one, then we can set the x label equal to weight. And if we just copy this, then we can modify it so that we then set the y label to height on both plots. And there are ways of getting it to share y labels, but for now we'll just leave it as it is. And then when you want to change the x to y, and so you can see that we've got some labels, although they're really cramped and it's not that clear. So what we'll do is we'll use the tight layout. So we take the figure, which we got from the subplots, and we just call the tight layout function. And this just gives us a bit more space. You can see they're no longer overlapping, and that's a lot clearer. And maybe when you run this, you want it to immediately be full screen. So the last thing we can do is we can get the current figure manager, which is referring to the figure, and then we can do a full screen toggle. And this means that the charts we create are going to become full screen. And there we go. So you can see we've created some beautiful charts using Pyplot as a submodule of Matplotlib. Hopefully you've got a flavour for what kinds of things you can do. Of course you're not going to be able to go away and create incredible graphs, but you are going to at least have some understanding of what you can do. And I encourage you to experiment with this and do some cool stuff, which if you look on the website you can see some great examples. So hopefully you've enjoyed this video, and I'll see you again same time next week. Till then.